Good morning, friends. How are you all? Hope you are doing well, especially in the pandemic COVID-19 time. So, this video lesson is a part of a series of video lessons. This is the third one in the series of the video lessons that I have delivered few days back. The first one we discussed about force and different types of forces, their magnitude, their units, all these things we have discussed. In the second video, we have discussed about force system or system of forces and various types of force systems we have. This video lesson is especially for resultant forces. In this video, we are discussing about a resultant of a collinear force system and resultant force of a concurrent coplanar force system. So let us start with, I have prepared a PPT, so let us go through it. So resultant of a force system. So basically, first of all, what is a force system or system of forces? If more than one force is acting on a body or on a system, that means number of forces are acting on a body, then we will call it as a force system or system of forces. And we have seen in the last video lesson what are the various types of force systems. Basically, two types of force systems we have. One is coplanar force system, the other one is a non-coplanar force system. Coplanar force system means the forces, all the forces of the system will lie on a single plane. That means coplanar. It will, all the forces will be on the same plane. Then it is called coplanar force system. If the forces on a body or on a system, if they do not lie on a single plane, then it is called a non-coplanar force system. In the coplanar force system, we have seen different types of coplanar force systems. One is collinear force system. Collinear means if all the forces are lying on the same line, then it is called collinear force system. If the in a number of forces acting on a particular point in a coplanar force system, then it is called concurrent force system. So here in this chapter, in this video lesson, we are talking about resultant of force systems, especially force systems of coplanar type. And that too in the coplanar also we are talking about, first one is collinear force systems and concurrent force systems. Okay. So to understand what exactly it is, so first of all, we have to understand what is a resultant force. My name is Anand Padavala. I'm senior faculty member in Government Model Residential Polytechnic. So this is situated in Gajwel. Gajwel is situated in Telangana state. So let us go with the resultant force. What is a resultant force? To understand what exactly resultant force is, so let us consider an example. We know that tug of war. Yes, we will take a rope and some group of people will be pulling from one side and the other people will be pulling from the other side. So two groups of people are doing a tug of war, and each group is pulling on a rope as hard as they can. See here. So here he is a referee. So two group of people, one group is on this side, the other group is on this side. So this is a tug of war. Mostly all of you, we know that we have played this. So when the middle point crosses this middle point to one side, that side will those people will win the tug of war. So here, though it is a game, but our collinear force system included here. See who will win in this. If they pull with more force, then they will win. Or if they pull with more force, they will win. If both will pull with the same force, what happens? No one will win, because the rope will be at the middle point only, because both of them are pulling with the same force. So here is a collinear force. Two forces are applying on one side and the other side. So this is a rope. So this is one set of people and this is the other set of people. If P is more, then this side, the rope will come this side. If Q is more, then the rope will come this side. If P equal to Q, then rope will not move. So this is a collinear force system. So resultant force will explain. That means what is the net effect of the force. So that's what a resultant force. So another one more example we will see. We have applied force. A trolley is there. Here we have seen 40 newtons here and 20 newtons here. And obviously 20 is more than 40. This wheel, this wagon will move this side. Trolley or wagon will move this side. We know that because the force is more here. But with what force it will move? That is what a resultant. Now we know that the resultant force will be 40 because 20, because 40 on this side and 20 on the opposite side, there 40 minus 20 newtons will be the net force acting on this side. Therefore, that net force is called a resultant force. We are talking about collinear system. Collinear system means the forces acting on a same line. See, if you see, they are acting on the same line. We will take one more example here. Here, if you see applied forces. So on the wagon or a trolley, we have applied 25 newtons on both sides. Then what will be the resultant force? What will be the net effect on this trolley? This is not going to be moved because both sides we are applying same force. Therefore, zero resultant. That means net force will be zero. So the trolley will not move any side. It will stay here. So with these examples, let us try to define what is a resultant force. So resultant force, when an object is subjected to several forces, the resultant force is the force that alone produces the same effect as all those forces. I think, hope you understood. So take a force system or system of forces. There will be several forces acting on it. If we replace all these forces with single force, and this single force should produce the same effect as all those forces, then such type of a single force is called resultant force. Instead of having many forces, we are replacing with a single force. For example, see here, there are two forces acting on this trolley. One is 60 newtons, the second one is 30 newtons. And if you want to replace these two forces with a single force, then what will be the net effect? And what happens to this force? This trolley will move this side. What will be the net effect on net force acting on this one? Because both are applying on the same direction. Therefore, 60 plus 30, 90. So if you want to replace with these two forces with a single force, that will be 90. Yes, there you are. So this is the force. This means this system is equivalent to this system. When we are talking about force system, this force system is exactly equivalent to this force system. Here we have two forces, whereas we are replacing with single force. So we can say that the resultant force of 60 newtons and 30 newtons in this direction is equivalent to is equal to 90 newtons of this side. So that means we are replacing these two forces with a single force which will have same effect on this. This will also give 90 newtons, this will also give 90 newtons. This is what a resultant force. Now let us take one more example. Now, two forces are acting on same collinear forces, they are acting on the same line, but they are acting on different directions. See, for example, if you take 30 newtons this side and 10 newtons this side. With a common sense, we can say that because 30 is more than 10, it will move this side. But what will be the net effective force? Because 30 this side and 10 is this side, therefore 20 newtons will be this side and it will be move like this. So if we replace with the two forces with single force, then this will be the net effective force, that is 20 newtons. So this 20 newtons, what we can say is a resultant of 10 newtons and 30 newtons given in this figure. Therefore, the resultant of these two forces will be 20 newtons in this direction. So resultant is also a force. Therefore, whenever we are talking about resultant, we have to talk about its magnitude as well as its direction. Without saying these two things, we cannot complete, because it is a vector quantity, we have to tell both magnitude as well as direction. So this is what a resultant. Hence, what is the resultant force? When an object is subject to several forces, the resultant force is the force that alone produces the same effect as all those forces. Here is the definition of a resultant force. Now we are talking about a resultant of coplanar concurrent forces. What do you mean by coplanar concurrent forces? As I said earlier, coplanar means all the forces of the system will be lying on the same plane. That is called coplanar. Concurrent means if all the forces in that particular system passes through a single point, a same point, then it is called a concurrent forces and concurrent force system. And the point where all these forces are called point of concurrency. So now we will talk about coplanar concurrent forces. Let us consider a body which have two forces perpendicular to each other. So here we have an object. This is a body. Two forces are acting different directions. They are not collinear. They are not in the same line. If the 4 newtons are here, then we can say that it is a collinear, but it is not collinear. These two forces are coplanar. They are on the same plane. Whereas under concurrent, if we look at this, they are not meeting. It looks as if it is not meeting at the same point. But if you extend the line of action here, 3 newtons and 4 newtons, they will meet at this point. This point is called point of concurrency. Therefore, these two forces, 3 newtons and 4 newtons, are concurrent forces. So this is a coplanar concurrent force system. So now we have to find out the resultant of this system. So let us consider what it will be done. So what 3 newtons means, when it is moving this direction, means 3 newtons it will move like this. 4 newtons means it will move like this. That means it is moving in two directions. One is this direction, the other one is there. First, let us see that this body is subjected to only 3 newtons first, then it will move. Then we apply 4 newtons this direction, then it will move to this side. That means the body will move like this and like this. For example, I have given an animation. And if at all the 4 newton is applied first, then the body will move like this. Then afterwards, if we give 3 newtons, it will move like this. That means the body either can move like this and like this or this. So finally, this body will move to this. This is the where the body is going to move. I have given an animation, see here. So this is the first case. So 3 newtons here and 4 newtons here. Now I'll come to the second case. See, 4 newtons here and 3 newtons here. However, anyway, if we take the 3 and 4, it will reach here, or 4 and 3, it will reach here. So this is how it happens. Therefore, if we replace the 3 newtons and 4 newtons, what will be the net effective resultant force? A single force if it is replaced, and how this resultant will be and in which direction it is going to apply. That we have to see now. So here is a force system, coplanar concurrent force system. P is here and Q is here. So if at all we want to, we know that a body is here. When we applied here, P here and Q here, the body will reach here. If we apply Q here and P here, then the body will reach it. That means the body is going to move from this place to this place. So if we can pull the body in this direction with a single force, this will come to this place. So this is how we have to find out the resultant of a coplanar concurrent forces. See here. Now P is this direction and Q is this direction. Now this arrow and this arrow represents Q, because they are in the same direction with the same magnitude. So with the properties of the vectors, here this vector and this vector are same. That means this is Q and this is Q. Similarly, this is P and this is P. So if we apply here P plus Q, it will be vector P plus vector Q equal to vector R. Vector Q plus vector P equal to vector R. Vector addition we are talking about. So this is how we are talking about. So how to find out the resultant? So the resultant will definitely act like this. With the common sense, see this, it has moved from this place to this place. So we have to find out a single force R, that is a resultant force, by replacing P and Q, which will have a same effect on the body as the P and Q gives. So R is a resultant force by replacing P and Q, and let us suppose that this resultant force will make an angle of theta with the P like this. So now let us try to find out the value of R. If you consider this triangle, see, this is the triangle I am talking about. This is a right angle triangle. This is a right angle triangle. This is P and this is Q, because this is Q, this is Q. Now this is P, this is Q, and this is R. So we know the Pythagoras formula, Pythagoras theorem. So P square plus Q square equal to R square. That means hypotenuse square equal to the sides, both adjacent sides. Squares, sum of the squares of the two sides. P square plus Q square equal to R square. Therefore, R equal to under root P square plus Q square. So the formula for the resultant forces, when we are talking about two concurrent forces which are making 90 degrees, that means which are perpendicular to each other, then the resultant force equal to under root P square plus Q square. This is the resultant force. And because resultant is also a force, therefore we have to give the direction, which direction it is moving. So if the theta is the direction, what is the value of the theta? We know that tan theta equal to Q by P. Q by P, because this is Q, opposite by adjacent. So Q by P. Now, therefore theta equal to tan inverse Q by P. Therefore theta is the direction. Therefore, if at all we want to find out the resultant of a coplanar concurrent forces, two forces which are perpendicular to each other, if those two forces are P and Q, and the resultant force R is equal to under root P square plus Q square, and theta equal to the direction, which makes with the force P equal to theta equal to tan inverse Q by P. Now let us come to our problem. This problem we are talking about. Therefore, this is 3 newtons this side and 4 newtons this side. How to solve this problem? Therefore, resultant, this is P and this is Q. Therefore, resultant R equal to under root 3 square plus 4 square. That is nothing but 9 plus 14 under root 25, 5 newtons. That means if we replace these two forces and if apply 5 newtons in this direction, diagonal direction, then it will be the resultant force. And the angle will be tan inverse Q by P. Q is here 4 and P equal to 3. Therefore, tan inverse 4 by 3. That means 53.13 degrees. That means the resultant force will be acting 53.13 degrees with the force 3 newtons in anti-clockwise direction. This is a resultant of coplanar concurrent forces. Now, we will go through one more case. Let us consider a body which has two forces acting shown in the figure. Here also we have two forces. Both the forces are concurrent and coplanar. But these forces are not perpendicular to each other. That means in the earlier example, we have seen if P and Q are perpendicular to each other. But now here, P and Q are not perpendicular. They are with some angle. Not only 90 degrees, 90 degrees is the case, whereas it is making an angle of theta, some theta. Theta can be less than 90, theta can be more than 90, or theta can be exactly 90. Then what we have to do this? So we know that a body will move like this and this. Definitely a resultant force will be somewhere like this only. But how to solve this problem? Earlier we have perpendicular forces, we have used Pythagoras formula and we have found the resultant. But now how to do this one? So here we have, this is P and this is Q. It is completing a parallelogram. That means by using a parallelogram, we can find out the resultant. For that, what we have to do? We have to draw a parallel force. That means parallel vector to P, force P through B. And similarly, we have to draw a vector, similar vector, parallel vector to Q from point A. Then this completes a parallelogram. When we complete this parallelogram, then the diagonal, this diagonal, which is passing through the point of concurrency, that diagonal will give the resultant force. So this is the force, the magnitude of the force, and this is the direction, that is alpha is the direction which makes an alpha degrees with the vector P or the force P. This is how we have to do. So this we can see, one such law is there, law of parallelogram, law of forces. So that will give the formula for the resultant when two forces P and Q are making an angle of theta. So actually we have a YouTube link, how this what is parallelogram law, and if we click on this link, you can get the video. First of all, let us go through the video. Let us understand what is parallelogram law of forces, and then we will come back and we will try to solve some problems. So now I am sharing the law of parallelogram.
Parallelogram law of forces. The statement goes like this. If two forces acting at a point be represented in magnitude and direction by the two adjacent sides of a parallelogram drawn through that point of application, their resultant is completely represented by the diagonal of the parallelogram drawn through that point. If two forces acting at a point be represented in magnitude and direction, then their resultant is completely represented by the diagonal of the parallelogram drawn through that point. Now let's understand the proof of this law. Let P and Q be the two given forces acting at O, represented in magnitude and direction by the sides OA and OB respectively of the parallelogram OACB. Let angle AOB is equal to alpha be the angle at which these two forces act. Alpha may be acute or obtuse. Click on the button case 1. Case 1. When alpha is acute, the resultant R is represented as magnitude and direction by the diagonal OC of the parallelogram OACB. AC being equal and parallel to OB represents in magnitude and direction the force Q. From the figure we have angle CAD is equal to angle BOA, that is equal to alpha, since they are corresponding angles. OD is equal to OA plus AD. Thus we get OD is equal to P plus Q cos alpha. Let this be equation 1. Also we have CD is equal to Q sin alpha. Let this be equation 2. Click on the button case 2. When alpha is obtuse. Angle CAD is equal to 180 degrees minus angle BOA, that is equal to 180 degrees minus alpha. Therefore, we get OD is equal to P plus Q cos alpha. Let this be equation 3. Also, we have CD is equal to Q sin alpha. Let this be equation 4. Thus, from case 1 and 2, we have OD is equal to P plus Q cos alpha. CD is equal to Q sin alpha. To find the magnitude of resultant R, applying the Pythagoras theorem to right angle triangle ODC, we get OC square is equal to OD square plus CD square. This implies R square is equal to P plus Q cos alpha whole square plus Q sin alpha whole square, substituting for OD and CD. Therefore, R is equal to root of P square plus Q square plus 2PQ cos alpha. This gives the magnitude of the resultant R. To find the angle between R and P, let theta be the angle which the resultant R makes with OA in the direction of P. Therefore, sin theta is equal to Q sin alpha by R, and cos theta is equal to P plus Q cos alpha by R. The value of theta, which satisfies these two equations, gives the angle between R and P.
So this is what law of parallelogram. So law of parallelogram forces we have seen. Now let us go to our current problem. Now we have seen this. Now parallelogram force. The statement says that if two forces acting at a point are represented in magnitude and direction by two adjacent sides of a parallelogram, then the resultant is represented in magnitude and direction by the diagonal passing through the point. It is very clear. So when two forces acting at a point here, acting at a point represented in magnitude and direction. So P with some magnitude in this direction, Q with magnitude Q in this direction, and they are adjacent and they are concurrent from point. So if we can complete a parallelogram with these two things have adjacent sides, then the diagonal which is passing through the point of intersection will be the resultant of these two things. This is what a parallelogram force is. And the proof also it is given in the earlier video we have seen. Now, so this is what, and the resultant force is equal to under root p square plus q square plus 2pq cos theta, and alpha is the angle of resultant which makes with the p, which is called tan inverse q sin theta by p plus q cos theta. So this is an important thing, law of parallelogram, and the resultant force is nothing but square root p square plus q square plus 2pq cos theta, and alpha equal to tan inverse q sin theta by p plus q cos theta. Now let us solve a problem. Find the resultant of two concurrent forces, 20 newtons and 10 newtons, are at an angle of 60 degrees. So the solution will be like this. First of all, we have to draw the figure, and the figure is here. Here is 20 newtons and this is 10 newtons. They are 60 degrees apart. They are concurrent forces. This is the point of concurrence. Now, how to do this? First of all, what we have to do according to the parallelogram law, these two, we have to construct a parallelogram by representing these two forces as adjacent sides of a parallelogram. So this is the parallelogram. This is 20 newtons and this is 10 newtons, and we have to draw a line from A parallel to this 10 newtons, and we have to draw a line from this thing. So OACB is a parallelogram which having adjacent sides of 20 newtons and 10 newtons. Now the resultant is the diagonal which passes through the point of concurrence, that is O. This thing will represent R, vector R is the force that represents resultant force, and it makes an angle of alpha with 20 newtons. So let us find out the value. We know that here P equal to 20 newtons, Q equal to 10 newtons, and theta equal to 60 degrees. According to the parallelogram law of forces, we know that the resultant R is equal to under root p square plus q square plus 2pq cos theta. So substituting the values of p, q and theta, so r equal to under root 20 square plus 10 square plus 2 into 10 into 20 into 60 degrees cos 60 degrees. So this comes r equal to under root 400 plus 100 plus 400 cos 60. And if we calculate r equal to under root 700, which comes 26.46 newtons. This is the resultant of these two forces. This is the magnitude. Now we will calculate the direction. Direction means the resultant force makes an angle of alpha with 20 newtons. So what we have to do, we have to find out the alpha. You know that we have a formula for alpha. Alpha equal to tan inverse q sin theta by p plus q cos theta. Substituting the values of p, q and theta. So alpha equal to tan inverse 10 into sin 60 by 20 plus 10 into cos 60. This comes around 19.11 degrees. That means this R is making an angle of 19.11 degrees with the force 20 newtons in anti-clockwise direction. So this is how you have to solve the problems, simply by remembering this formula. R equal to under root p square plus q square plus 2pq cos theta, and alpha equal to tan inverse q sin theta by p plus q cos theta. Now let us see some more problems here. So here we can solve the problems and by graphically also. For example, now see here, 20 newtons and 10 newton. Determine the magnitude and direction of the resultant of these two forces. So what we have to do is construct a parallelogram by drawing two lines. So here is each line starts with the tip of the vector. This is the tip. Here we can go like this. So after constructing, these are the two opposite sides, and this represents the resultant. For example, if this is 20 newtons, 200 newtons means, for example, if we take 20 centimeters, and if this is, we have taken 15 centimeters, and the distance from this point to this point, how much it will be, the same will be the resultant. And the direction also, how it will make, what is the angle it will make from this, that is, we will see. And we will go through one more problem here.
The problem is given like the two forces are acting at a point O as shown in figure. Determine the magnitude and direction of the resultant force. That means here the two forces are acting at a point O. Assume that point O is one of the points on the body. So we need to determine the resultant force of the two forces acting on the body here. So the figure is given like this. So here this corner point is O. So on this point the two forces are acting away from the point as P and Q. P is 50 newtons and Q is 100 newtons. And here The angle made by the P with a horizontal line, it is given as 15 degrees, and the angle made by the Q with respect to P is given as 30 degrees. So for these two forces, we are going to find out the resultant force, which can produce the same effect as the two forces acting at a point O. Okay, that means the resultant force will represent the two forces, okay, that can produce the same effect as the two forces acting on a body. So here for that we follow the parallelogram law of forces. So already we have discussed about the parallelogram law. So we, by using this law, how can we find out the resultant force? Already the derivation part is explained in the previous lecture. So by using that formula, here we are going to find out the resultant force of two forces P and Q here. Here first we need to assume the two forces as two sides of the parallelogram. Here the two forces are P and Q. So we need to assume these two forces are the two sides of the parallelogram. Okay. And next, and here, so here we have assumed the two forces as two sides of parallelogram. So then the resultant will be the diagonal of the parallelogram. So the diagonal will represent the resultant of these two forces when we assume these two forces are the two sides of the parallelogram. So already we have discussed the formula will be the resultant force is given by the formula r square is equal to p square plus q square plus 2p cos alpha. So we need to substitute the values here. So according to the problem here, p is equal to 50 degrees and q is equal to 100 newtons and alpha is 30 degrees. Okay. So the alpha represents the angle between the two forces which we are assuming as two sides of the parallelogram. So we need to consider this 30 degrees only. Okay now. So the alpha is equal to 30 degrees. So now substitute the values in the given formula for finding the resultant force. So r square is equal to p square means here 50 square plus and q square means here 100 square plus 2pq cos alpha means 2 into 50 into 100 into cos 30 degrees. So by simplifying these values, we can get the resultant force. So here r equal to, we can write it as square root of same term 60 square plus 100 square plus 2pq, that is 2 into 50 into 100 into cos 30 degrees. So by simplification we'll get r is equal to square root of 21,160.25, and by taking the square root of this value we'll get r is equal to 145.46 newtons. That is the resultant force of the two forces P and Q, which will produce the same effect as the two forces P and Q acting at a point O on a particular body. Okay, so that is the way of finding the resultant force of two forces by following the parallelogram law of forces. So next we try to find out the angle. So what is that? The resultant force, diagonal means it can pass through the intersecting point of the two forces. Okay now. So that means from O only the resultant force will be getting as a diagonal of the parallelogram. So for this resultant force, we can also find out the theta angle, that is angle made by the resultant force to the adjacent side, that is P force. Okay now. So this theta value can be determined by the formula theta is equal to tan inverse of q sine alpha by pq cos alpha. So for this one also a particular derivation part is there. So by taking tan theta is equal to, we can derive the formula. So I didn't explain that, but please remember this formula theta is equal to tan inverse of q sine alpha by p plus q cos alpha. So again substitute the values in this formula equal to tan inverse of q means 100 sine 30 degrees by 50 plus 100 cos 30 degrees. So by simplifying this equation, we'll get the theta value as 20.1 degrees. That means here the theta is the angle made by the resultant force with the adjacent side or adjacent force, that is P value. Okay now. So like this we can find out the resultant of two forces by following the parallelogram law of forces, and again we can also find out the angle made by the resultant force with its adjacent side, that is by the formula tan inverse of q sin alpha by p plus q cos alpha. So I hope you understand. If you still have any doubts, please feel free to give.
Hope you have understood the law of parallelogram or forces. So in this video, so far we have discussed about what is a resultant and how to find out the resultant in case of collinear forces. Collinear forces is very simple. So they lie on the same line, therefore finding out the resultant will be very easy. And regarding coplanar forces and concurrent forces, coplanar concurrent forces we are talking about, we have discussed about, and in that we have talked about only two forces which are making an angle with some alpha. If alpha equal with theta, and if the theta is 90 degrees also, what happens we have seen. So hope you have enjoyed this video. So we will try to do some more problems. That means in the coplanar system of forces, if we have only discussed 2 to 3 forces, or 2 forces only. But if we have more than 2 forces, what to do? We can't apply parallelogram. Parallelogram law can be applied only in case of coplanar forces, coplanar 2 forces. If the force is more than 2, then we cannot apply this what we say law of parallelogram. So parallelogram law of forces can be applied only to forces, to coplanar concurrent forces. But in real scenario, we will have many number of forces will be applied. Even in coplanar also, there will be number of forces will be applied. So in that case, how to solve this one? So in the next video lesson, we will try to solve when a coplanar force system having more than 2 forces, that is 3 or 4 or 5. To solve this, what we have to do is we have to go for resolution of forces. So by making all the forces into 2 components, that is horizontal component and vertical component, and net effect of all horizontal components and net effect of all vertical components we have to see. And based on that, we will replace the entire force system into only 2 forces, one horizontal force and one vertical force. Then when we have a vertical force and a horizontal force, then we can use a formula from today's lecture. We have seen that r square equal to p square plus q square, or r equal to under root p square plus q square, and theta equal to tan inverse q by p, like that. So in the next lesson, we will be talking about resolution of forces, and resolution of force is nothing but splitting a single force into 2 components. That is, one is horizontal component and a vertical component. And by resolving all forces in a system, so net effect of what and sum of all horizontal forces and sum of all vertical forces we can find. Hope you have enjoyed this one. And this video lesson is especially used for diploma students, diploma 3rd year students, where they have a subject called solid mechanics. So this video is especially prepared for the diploma students. Even other graduates, other engineering graduates, or those who are physics graduates, they can utilize from this. Thank you very much for viewing this one. If you have enjoyed this video, please share this one and like this one. Thank you.